Why do metallurgical changes occur in the welding HAZ? Imagine welding a metal piece and noticing that the area right next to the weld looks different from the rest. That's because of what happens in the heat-affected zone. When you weld, the metal around the weld gets really hot, but it doesn't melt. This high heat causes changes inside the metal's structure. Think of it like baking bread. The heat changes the dough's texture without turning it into a loaf. In welding, the heat causes the metal's grains to grow larger and can change the internal phases or structures. For example, in steel, heating above a certain temperature turns the crystal structure into austenite. When it cools down, it can turn into different microstructures like martensite or bainite, depending on how fast it cools. These microstructures are what give the metal its hardness or toughness. The amount of change depends on how much heat is applied and how quickly it cools. If the heat input is high, the grains become coarser, which can make the metal more brittle. If it cools too fast, it might form hard but fragile microstructures like martensite. On the other hand, slower cooling can lead to softer, more ductile phases. The type of metal also plays a role. Metals with higher carbon content tend to form harder microstructures when cooled quickly. The original microstructure of the base metal before welding influences how it reacts to the heat. For example, a fine-grained metal might become coarse and less tough after welding. Welding processes like shielded metal arc welding, gas metal arc welding, or tungsten inert gas welding each deliver different amounts of heat. The choice of process affects the size and severity of the metallurgical changes. Higher heat input usually means larger heat-affected zones with more microstructural transformation. Controlling these changes is important because they impact the strength, ductility, and resistance to cracking of the welded joint. Techniques like preheating the metal or post-weld heat treatment help manage these transformations. These steps slow down cooling or alter the microstructure to make the weld more durable. In manufacturing, understanding why these changes happen helps engineers select the right welding process, parameters, and materials. It ensures the final product can withstand stress, fatigue, or corrosion without failing. The heat-affected zone is a zone of transformation driven by temperature, making it a key focus in welding and manufacturing. Proper control of this zone ensures the welded structure performs as needed in real-world applications.